Okay, so now I want to talk to you guys about Ohm's Law. I got you a little picture here of Mr. Ohm so you can see what he looks like. Some people say he looks a little angry, but not so quite sure that's what's going on here, but who knows? All right, so the first thing that we want to talk about when we talk about Ohm's Law is voltage. And you guys should be aware of the fact that a voltage can be produced by a battery. We did talk about a battery last unit when we talked about energy. So you know that with a battery, it first takes that chemical energy, and then when you place it into whatever the device is, it will convert it then into electrical energy. Well, a generator is how most of we get our electricity, possibly here at school or at your house. Some of you are familiar with generators through tailgating at some of the sporting events. So generators, what they do is they actually take mechanical energy. So they're taking some type of movement and it will produce electrical energy. We also have a motor, and a motor, I tell you guys many times, just to add here, a good example of a motor would be like a fan, because it takes electrical energy and it converts it into mechanical energy. And I tell you to think about a fan simply because if you think about it, it's plugged into the wall, so you get that electrical energy first, and then you see that movement of the fan blades because there's a motor that's running that. So sometimes that's helpful for you guys. All right, now when we're talking about Ohm's Law, the very first variable of Ohm's Law is voltage. So let's talk about voltage. Voltage will be symbolized by the letter V. The definition of voltage is the electric potential energy per charge. If you think about voltage, many times you can think about those batteries that we just discussed. So if you think about those batteries and how you have that chemical energy, it's like stored up energy. So sometimes that helps you to remember that it's the electric potential energy per charge, because it can be changed into that electrical energy. What voltage actually does, though, is it provides the energy that pushes those electrons through the circuit. So if we're talking about like an actual circuit with like battery, wires, light bulb, whatever it is that we may be trying to power, the voltage source, like your batteries, is what gives that energy that pushes those electrons through. The clothing, the unit for voltage. So when we are doing our Ohm's Law word problems and we have to put a clothing on a voltage, is V, which is just volts. Okay, since we are talking about a battery, I do like to show you this little diagram of the battery. Many of you know that, like, if you cut open the battery, of course, there's that paste in there that can harm you. But I usually like to show you guys this because two things. Most of you are aware you have a positive terminal and then you have a negative terminal. But some of you aren't aware of the fact that you have this carbon rod. And so this is where those electrons are going to push through here, and they're going to go through that carbon rod, so in order for the electricity to begin working. All right, with your voltage, if you notice here, we are going to talk about circuit diagrams in a little while, but this is just a little diagram of a circuit. It shows you this long line, short line represents the batteries. So the shorter end is your negative terminal, the longer end is your positive terminal. And this, of course, is just your little wires going around. And this is just some type of a device. Maybe it's a fan. So if you look at this, you should see this should be very self-explanatory that in a battery, you have that positive terminal and that negative terminal. So with a positive terminal, it would have fewer electrons. So when you don't have as many electrons, of course, then you have a positive charge. However, the negative terminal has a lot of electrons. So since they're hanging out on the negative end, therefore we call that the negative terminal. All right, what you should take away from the whole battery concept is that electrons are pushed from the negative terminal towards the positive terminal. So you need to know that the flow of the electrons in a circuit go from negative to positive. I always tell you guys that this is backwards because if I were to turn this onto a big slide here, you can see those little line or the little dots going around. So I always try to tell you guys that this is backwards simply because when you look at it, it shows you like we're going from the positive to the negative. But what their concept that they're really trying to show you is it comes out the negative through the positive and then around. But it can get a little confusing. So your big takeaway is that the electron flow is from negative to positive. All right, the second variable in Ohm's Law is current. And current is kind of weird, but it's symbolized by the letter I. And current is the actual flow of the electrons through the conductor. So you've got the voltage, which pushes those electrons out there. And then the current is actually how they're flowing through that wiring The clothing for current, a little different. It's amperes or amps. Most of you may have heard of amps before, or you can symbolize it with a capital letter A. With current, it's a little tricky because it starts with C, the letter is I, the clothing is A. I did have a student a few years back say, oh, that's easy to remember. It's CIA, like the government. So whatever you can do to help you remember the different letters and variables, I would suggest trying to do so because that one does get a little confusing. All right, the last and final variable in Ohm's law is resistance. Resistance is symbolized by the letter R. Resistance happens when electrons flowing through a wire run into insulating materials and bounce around. If you think about resistance, if you're resistant to anything, that just means you're kind of hesitant. You kind of stop. You may, stop to think about it or whatever. So I tell you guys that that's what resistance is here in a circuit, is where it's actually opposing that electron flow. There's something slowing it down or stopping it. So that's why I put a big stop sign to help you remember. All right, with resistance, the clothing or the unit that goes on resistance is ohms. So this is where Mr. Ohm comes in. And it's this little horseshoe looking guy. All right, so the way that you can have resistance in a circuit, there's several different ways. So these are just some of the sources. You should know that resistance does produce heat. So you got, the electron flow that's getting, opposed. So that heat's going to build up. But things like longer wires, when the electrons have a longer pathway to flow, they are going to cause resistance. They are going to want to slow down. There's actually resistors, and some of you may have opened up some kind of electronic device and seen something like this, and this is an example of a resistor, and they actually just pull back the electron so that possibly it doesn't go through the circuit and like blow the light bulb or whatever the object is. Light bulb filaments themselves cause a little bit of resistance, so after a light bulb, you will have a little bit of slower flow of electrons. And then, of course, other electrical devices. So the more devices you add into your actual circuit, the more it's going to cause that resistance. All right, so here's the actual equation for Ohm's law. It is V is equal to I times R. So voltage is equal to the current times the resistance. What this basically tells us here, if you notice that this is just a little diagram to show you that if the voltage remains constant, notice that one's going to go up and one's going to go down. One's going to go up, one's going to go down. So when voltage remains constant, one goes up, one goes down. And that's what this one here tells us. So, the very first point, when voltage stays the same, one will go up, one will go down. Now, the difference is that with resistance and current, let's say that one of those stay the same. If one of those stay the same, then the other two variables either both go down or they both go up. So if current stays the same, both go down or both go up. Okay, Ohm's law. So if you increase the voltage and the resistance stays the same, so if you keep holding back those electrons, then obviously and you've increased the amount of electrons that are flowing through, then obviously the current should also increase. However, if you decrease the voltage, let's say you take a battery out of there and the resistance stays the same, then the current will decrease because you've lessened the amount of actual electrons flowing. If you increase the resistance and the voltage stays the same, so you've put more things in there to cause it to slow down, then the current should decrease. If you decrease the resistance and the voltage stays the same, so we keep the same amount of batteries, but we decrease the objects that are in there, then of course that current should increase and cause a bigger flow. All right, a couple of examples here. Let's say that we have a 7 ohm resistor and it has 2 amps of current in it. What is the voltage across the resistor? I am not at school to show this to you, but most of you are smart enough to know that we're going to use that V is equal to I times R equation. So if we look back at our problem here, it's asking for voltage. So all we're going to do is multiply 7 times 2 to get 14 volts. Our next example says a 3-volt battery produces 6 amps of current through a flashlight. What is the resistance in the flashlight? So this time we're looking for R. So we're going to take our voltage and we're going to divide it by our current to get 0.5 ohms of resistance. And that should do